also called Kirchhoff's rules. First, we have the junction rule that says if you have a line that splits up, you have any kind of junction, then the current in equals the current out. The sum of all the currents into that junction equals the sum of all the currents out of that junction. This is conservation of charge. That's really where this comes from. It's one of our fundamental conservation laws in physics. The current into a junction would equal the current out. So in a simple junction like this, my current's coming in and it's splitting up. Let's call this I2, I1, I3. Then I1 must equal I2 plus 3. All the current in equals all the current out. Okay, then we have our loop rule. That says around any closed loop, no matter what you've got in there, resistors, batteries, that's all we'll have in these. All the way around the closed loop, the sum of all the voltage drops and rises will equal 0. This is conservation of energy. Okay. Now, here are some conventions that we're going to use to make this easier on ourselves. So if I've got a battery, the big end is the positive side, the low end is the negative side. I'm going to draw this the other way. Any current that flows through a battery the correct way from negative to positive. Remember, current is flowing out of positive generally, flowing back around and then back into a negative. So we think of the current as flowing through the battery from negative to positive. We'll consider that to be a voltage rise. So that will be a positive change in voltage. And if I go through a battery backwards, so if my current comes through and goes positive to negative, we'll call that a voltage drop. Going through a battery the correct way is a rise. Going through it backwards is a drop. And anytime voltage goes through a resistor, or anytime current goes through a resistor, that's a drop. So think of, remember, all of E&M was formulated in terms of hydrodynamics, water flowing. They literally thought of current like water flowing. And it's a really good analogy. So if I've got, I don't know, let's take our simplest circuit we could have. A battery with one resistor. My current's going to flow out of the positive end of the battery, flow through the resistor, back into the negative end of the battery. This is physically like you're lifting, the battery does work. It physically does work. Lifts the voltage up. So here's the battery lifting, putting energy into the system, into these little charges that are flowing around. The battery lifts them up. Every time we go through a resistor, we drop back down. Now we're back down at 0. Then the battery lifts us back up. We go through the resistor and drop back down. So if I had 2 resistors on here, it would look like steps. We would go down a little bit and then go down a little more. Every resistor is a drop. Every battery is a rise if we go through the battery the correct way.